Hey there, Deborah and Paul. Can you guys hear? You guys can see me, you can hear me.
I can hear you,
Okay.
and let me get back
Okay.
to.
Can hear you as well.
Great. I just want to make sure that that's working. Oops.
Yeah, Paul, meet Sheila Mendez. Sheila, Paul, Boris.
Hi,
Sheila.
Nice to meet you. Look forward to hearing you speak today.
Thanks. Pleasure to meet you.
Likewise. I'm just going to move some stuff around.
Number of people who are so diligent, who got on early. It seems like this is where we should have the elevator music playing.
Why don't you sing for us, Deborah?
Oh yeah, that probably wouldn't be pretty. Sheila could do the Lobo fight song, probably.
I don't think so. You would think I would know it by heart, but not really.
So I'll make all these slides available. I'll send a download link, Deborah, so if folks want to, want the slides for any reason, they can download them and take advantage of them.
Okay, perfect. I believe Ava should be able to even, she can probably load them into maybe your profile or into your speaker profile.
Yeah, I can make them available on the event app as long as we're authorized. I'd be happy to do that, and they can live there.
Yep, you are authorized.
Perfect.
Sheila, are you actually outside?
No, that's just my background. That's actually my wedding altar.
Very nice.
Husband and I, when my husband and I got married last year, we're diehard, obviously Lobo fans, but we actually had a tailgate wedding out at the football fields. And so we did it during the Lobo Aggie game last year. Big hoorah, and it was probably so much fun.
Oh, that's fun.
Yeah, everybody got to, have a beer and drink wine and, while we were getting married. And even we had President Stokes come out and Eddie Nunez, which is the athletic director, and his staff. And we just had a ton of people around. And then the band came around and played for us. And the news was there, KOB. They even did a story on us because it was a good field story. So that's still like on their website. If you go to KOB and then look at tailgate, Lobo tailgate wedding, you'll find our clips that they were running that week. Yeah.
I'm going to look that up. That sounds like a lot of fun. That's a great way to do it.
It was a heck of a fun time. We had a great time. That's how we actually met at that same tailgate lot 8 years prior. And so
we decided, made perfect sense.
It was. I'm like, oh, I want a tailgate wedding. We even brought in a little like a trailer so that we could park it there so we can go change from our tailgate clothes into our actual, clothes. And my husband's oldest son actually officiated from the World Wide Web, got officiation. And then all of our kids, my two boys, walked me down the aisle, and then his other 3 children were right on his side. And so we had a teal and a red theme. So it was cool. It was a lot of fun.
That's cool. That sounds like it was a great time for everybody, right?
Oh, it was.
You two and everybody that got to join you. So that's pretty cool.
Yeah. A lot of fun. So Ava, how do we know when we're supposed to start, or you're not letting people in until?
We have 88 participants. We are live actually.
Okay.
So we were just waiting for a couple minutes past the hour because those numbers are going up steadily, just giving people some time to jump on. But whenever we do want to get started, Sheila, I will be running your slides, and then we'll turn it over to Paul and we'll get going. But yeah, those numbers are creeping up, so that's good to see.
So sorry for everybody who had to hear my little story there.
I'm sure they all loved it.
A couple people in the chat window said that it sounded like it was fun. So.
Yeah.
Nope, you're on mute, Deborah.
But you were on the news, so I guess it is a public story, huh?
Yeah.
It was a public story.
And Paula just posted everyone's a Lobo, woof, woof, woof.
Woof, woof, woof. There you go. Get my little things out there.
Nice,
I even have my Lobo shirt on.
nice. That's what Thomas just said too. I love the story and I love the Lobos. So, Sheila, if you know, whenever you're ready, if you'd like
All
to.
right. Looks like we've got about 99 participants, so we know that more people will be jumping on as we go along. But let's go ahead and get this party started. Well, first of all, good morning, everybody, and welcome to the New Mexico Technology Council's 2020 Virtual Experience IT Conference. I'm Sheila Mendez, and I am the board chair and also the director of Operations Technology and the PPMO at PNM Resources. So the New Mexico Technology Council is a member-driven organization with a focus on supporting technology community throughout the professional development, networking, public policy, workforce development initiatives. So if you're not a member and just joining our conference, I'd really encourage you to reach out to us and receive some more information, because we'd love to have you be a member with our organization. Now, although we cannot be in person, so we're very disappointed that we couldn't be presenting this excellent conference in person, but with today's world, we are having to adapt and be very agile very quickly. But we still think that you're going to have great opportunities to be able to continue to network with each other during the event. We're excited to, our program, wow, is filled with some content experts on a variety of relevant topics, including like digital transformation, artificial intelligence and machine learning, cybersecurity, data science, healthcare, digital learning, aviation, and space initiatives. So that's pretty cool. We have two internationally renowned keynote speakers to kick off the day with a dynamic and informative actually presentations on digital transformation, the Internet of Things, artificial intelligence, and machine learning. And Deborah will be announcing our first keynote here shortly. But following the keynotes for today and tomorrow, we have included time for you to go into our expo hall. So please make sure that you downloaded your app and you're coming in through the website. And learn more about our sponsors and our exhibitors, and please take some time to visit some of their booths there virtually. We also want to thank our conference sponsors for their generous support of our experienceIT. And here I want to be able to call them out. Our founding sponsor is Comcast, with our goal level being the City of Albuquerque and Fat Pipe, New Mexico. On the track level, Nusenda Credit Union, Oracle, and Presbyterian. On our Sapphire level, we have A&M, ABBA Technologies, CenturyLink, Cisco, Kosh Solutions, New Mexico Manufacturing Extension Partnership, and Tech Systems. And on our innovation level, we have AWS, Bridgers and Paxton, Deploy Hub, New Mexico NetLinks, New Space New Mexico, PADT, Rural Sourcing, Sempris, Synchronous, also formerly known as New Mexico Health and Information Collaborative, techedin.com, and Virgin Galactic. I also want to thank the continuous generous support of our New Mexico technology community partners shown here, right? Which none of this would be possible without you. We're so grateful to have this wonderful and engaged board of directors. They are fantastic. They really stepped in and really helped lead this, this charge and bringing this wonderful experience for you. They're in many different respective technology areas, and I'd like to thank them and say thank you for your continued support. And our New Mexico technology staff, I could not say more about their tirelessly effort, right, and putting this together and really thinking outside of the box and finding how to make this conference really enjoyable and so that it's supporting what your needs are. They put it together with the help of Mark Reynolds from UNM and Mark Leach from the City of Albuquerque and Josh Fistow with Cost Solutions, along with many others who help support us. So get out of the office and stand up and enjoy these 2.5 days of relevant information. the spark, your creative thinking, and hopefully you take some of this information back to you, back to your office, and use it for your continued professional development and maybe some changes that you want to make in your organization. So thank you for joining us today. And now I'm going to introduce Deborah Brightfield, our Executive Director for the New Mexico Technology Council. Deborah.
I figured I better make sure I'm not on mute again. Okay, thank you. Good morning, everyone. Thank you so much for joining us today. I'm Deborah Brightfield, the Executive Director of the New Mexico Technology Council, and want to welcome you to our annual experienceIT conference. This conference is really a tribute to all of you in the technology fields, keeping your entities and businesses and clients functioning and running at top capacity during this time. And I want to thank all of you for attending. You will be impressed and gain excellent content from our group of outstanding speakers who are experts in their field. Again, as Sheila mentioned, our generous sponsors, members, board. Also want to thank our peer group committee members who continue to bring top-notch learning opportunities to the Tech Council and our program of work throughout the year. And thank you today to our speakers, our moderators, our volunteers, and also to UNM, the University of New Mexico's UNM's IT department, who's assisting us with technical reassurance today throughout all of our sessions. I just really quickly want to thank my NMTC colleagues for their exceptional work on bringing this conference together. Mary Tiemann is our Community Affairs and Membership Director, and Ava Montoya is our Marketing and Events Manager. And I just have to say I'm honored and privileged to work with these outstanding women. So I hope you can, as Sheila said, kind of get out of the office, block some time, and enjoy our 2 days of keynote speakers and a diverse variety of sessions that we have for you. Take advantage of this outstanding opportunity to dedicate time, for your own professional development and with these expert-filled sessions. So now it is my honor. I had the privilege to hear Paul Boris a couple of years ago when he was here in New Mexico, and he did a keynote presentation for the MEP, the NMMEP, and I was just transformed by it and just fascinated. So I kept his business card, and I'm thrilled that we have him here today. A leader in digital transformation. So he's the EVP and Chief Revenue Officer for Praemo. He's a digital transformation and industrial Internet of Things, advanced robotics, and AI is the title of our session today. Paul's a thought leader on industrial Internet of Things and digital transformation. He launched GE's brilliant factory lab. Really, I think back in, a number of years ago, big data, software sensors, controllers, and robotics. He was a real leader, and he continues to be a thought leader on topics that related to the industrial Internet of Things. So he has extensive internet and industrial experience, and he has driven digital transformation within industrial operations for decades. When Paul was the General Vice President of Enterprise Operations at SAP, and he also was the CIO of Advanced Manufacturing Solutions at GE. So with that, I'm thrilled and happy to turn it over to Paul Boris, our keynote speaker today. So thank you so much for being here with us, Paul.
Thanks, Deborah. Thanks, Sheila. And thanks to everybody that's joining. I've got a little bit of an allergy situation, so you'll see me take a sip of water from a bottle on occasion. I apologize for that. I'm going to share a screen here and bring up a presentation. And you'll see me look down on occasion. What I'm actually doing is I'm working on my iPad, and I'm going to be able to illustrate a little bit as we go along. So thanks again. This is a great opportunity to speak with everyone. I'm going to try to give you a few things to think about with respect to digital transformation and really how robotics and things like additive manufacturing and all of these different parts and pieces are really bound together with the thread of all the data that runs between them. This is really the only slide that I'll have with respect to my company. We're actually a data and analytics company. So we provide an analytic engine that really takes advantage of this data, and it's meant to be to move initiatives far faster than they do at this point. So we'll leave that commercial behind and kind of dive into some of the things that I think are really transformative in the space. So my background's manufacturing. I started in operations literally just a couple weeks out of high school, and spent a lot of time running manufacturing facilities, about 10 years with SAP, 4 years as the CIO for advanced manufacturing strategy at GE. And you know, the advances that are occurring in robotics, in additive manufacturing, in spaces like data connectivity, and you know, this is relevant. I looked through the list of folks that are joining, and this is relevant, I think, frankly, to everyone, because it's about how we advance our operational capabilities in the manufacturing space. That's where I cut my teeth, and that's where my heart is. So if I say something that sounds like I'm picking on them, it's just not the case. I have the greatest respect for folks, but those are really the foundational elements. If we want to do things, I believe, in the community that drive communities and drive you know, living wages and organization, and really drive the you know, how we upgrade and drive our communities forward. I think we start with things like manufacturing. It's a great place, and it's a fundamental to what we do. Things to touch on. I mean, if you look at, and I've included the links here, you could read these things more deeply, but think about how additive manufacturing has impacted the space. Now, one of the problems, I'm going to try to give you a view of here's the opportunity and here's the problem, because I think the way to navigate through the problem is far easier than most people realize. But in this case, we're talking about this catalyst engine that GE built. They actually took 855 different components in that engine and boiled them down to 12 via additive manufacturing. The fact that you can not only alter how you manufacture parts, but alter the engineering associated with them, the things that you can do to the part that you couldn't physically build up a part, but now you can do it from an additive manufacturing standpoint. So it's a huge wave, but it's one of those items that seems like a kind of a tough nut to crack, because it's kind of more hobbyist right now for most people. It's more prototyping. It hasn't really reached the space where we're building a lot of end items. This catalyst engine is clearly one of those end items that's a tremendous impact. If you look to the upper left, there's an interesting article from the Wall Street Journal about just, I think in the last week or so, about using robots and automation in stores. And I don't know if anybody's seen these things, but the idea is to send a robot up and down the aisles of a grocery store. So this is as people, you can see the woman picking groceries off the shelf, purchasing items, and the robot meanders around the store, and it casts a beam of light, and it's actually doing an inventory as it moves up and down the store. Now, robots, if you're in the industrial space, you remember them for many, we've had them for years, but we used to put them in a cage because they were so dangerous. They become unwieldy. They could literally kill you in a production environment if they're not properly programmed, and if they're not enough fail-safe situations. Now we've got robots in the space. Even in the manufacturing setting, we have cobots. We have a robot that will actually stand right next to you at the assembly line and maybe lift the heavy part while a person guides it into position. And the reality is, what Walmart found is they pulled these robots. They pulled them out. They didn't see the value that they thought they would get back from it. Big projects, big things, this catalyst engine, it's a big project. These are hundreds of millions of dollars worth of investment in R&D. These robots at Walmart, the same thing. And in the lower left here, we see that a lot of manufacturing still looks like it did, quite frankly, decades ago, maybe even in some cases a century ago. Clearly safer, cleaner, much more rewarding environment. But operators standing at a piece of equipment and focusing on things. The company in the lower left is a company called VibeCo. They're a great organization out of Rhode Island, and they're very focused on lean, but it's a small company. They do very complicated things. They're a low volume, high mix organization. And really the common thread between all of these, and I think this is where the huge opportunity lies, is this construct of being able to accumulate this data, to get it to the cloud, and then either at the cloud in a very robust way, or even at the edge where we're talking about at the machine or this catalyst engine or this robot, we can run artificial intelligence type technologies or algorithms, things like machine learning, to drive the process in a whole different way. So the way the data thread is wound around everything we do is really a huge opportunity moving forward. So a couple questions that we'll try to touch on in this discussion. And like I said, if you've got the chat window up, fire some questions forward. Deborah's going to keep an eye on the Q&A as well, and we'll try to work them in, but we'll save a couple minutes as well. But people, when they think of data and they think of AI, machine learning, it's about getting it all into one spot, getting it harmonized, and cleaning it up. If you go and spend any time in operations, you're going to hear our data is garbage. And I'll challenge that as we get through this discussion. But this is one of the big topics. We need to get it all scooped up, cleaned up into the same spot. We understand that this transformation, this construct of digital transformation, getting machines and people working together, it has a huge ROI, and that usually comes with some very big project budgets. So if we're going to put that kind of effort in, and we're going to get that kind of a gain and that kind of expense associated with it, we're going to build up a really big team, and we're going to put a lot of people in place that are focused on this. And we need to put a study in to kind of figure out where to start. So if we're going to train our sites on something, if we're going to put a searchlight on something, we really want to understand how to do this. Now, I'll come back and I'm going to debunk all this, because I think this is typical. It's completely logical. I understand exactly how people get to this point, but I can tell you for certain that this pushback, this desire to wait to get everything aligned is really unnecessary. And it's based upon this convergence that's going on for quite a while, where data is now secure in the accumulation of it, the movement of the data, and then the ability to put it in the cloud, and the ability to run that kind of intense algorithmic review of the data, both in the cloud and back down at the edge at the machine. So let's go way back. Start at the start with this. This is really what I think kicked off the idea of the industrial Internet of Things. And it's a great paper from one of the authors is a friend of mine from GE, Marco Annunziata. He does a great job. He's got a great blog. If you want to follow somebody, he's pretty entertaining and very enlightening. And this paper is worth reading, because where my mind goes is, we've talked about very small incremental gains, 1.5 percentage point gains, and a $15 trillion impact. And since this time, this is about a decade ago, since this time, everybody's kind of retraced from that. They said, well, it's not going to be 15 trillion, it's going to be 5 trillion, it's going to be less. Here's the problem, here's all the issues. I don't think any of the fundamentals in this paper have changed. I think what has happened is we've done what we typically do. We take something that's viewed as part of a foundational infrastructure, and we turn it into a solution in and of itself. IoT became a solution in a lot of people's minds. Big data, data lakes, they became solutions. And when those solutions didn't produce tangible value, then they get discarded fairly or unfairly. And people really struggle to say, okay, how do we do this again? Somebody's doing it better. We've already done that. Why would we do this again? So where are we a decade later? This slide is over 10 years old. This is really what manufacturing looks like. We've got our, I say we go from the carpeted side of the operation to the concrete floors over here. This is our ERP and our business systems. These are our manufacturing systems. And for a decade, we've been saying, okay, let's put data in. There's a great study in the lower right here. It's actually a study of studies. And the point of this is to say, if I were to use data or an algorithm, who would make a better decision? And what they found in 48% of the cases, actually studies, it was a toss-up between the human and the algorithm. The algorithm won about 46% of the time. So I could be right, leaning on the algorithm 94% of the time. The human, the expert, and in manufacturing, this is the expert because I've been here 30 years. I've run this machine, I've run these parts, I've run this process quite a long time. I know what's going on here. And we start to cloud the understanding of a process from being an expert around how to use data. And that's a problem. So all of these systems and all of these different solutions and opportunities we've had, here's where I actually make things at the plant floor. I have all of these systems. They're not really different systems, frankly. They're different views of data that I've accumulated down at the plant floor and that my customer needs or wants to get product to them. I know data is the answer. You would think if I took an approach to be aggressive around this, I'd have a huge impact. What we've done is we've crashed industrial productivity over the last decade. The internet's arrived. We're finally on the plant floor. We're getting email. And I've been in places where I didn't have email on the plant floor, right? You'd have to go in the office and call somebody to find out what was going on. I've been around it a long time. Despite all of this, we've still crashed productivity. We've not seen the gains. It's not because people are lazy. It's not because they're not smart. It's not because they're not paying attention. It's because I think the focus has gone on to things that are foundational as solutions as opposed to enablers. And I'll give you a few examples of that. But before I do, let me just talk about how this typically rolls out in an operation. So we start at some point in time with something. Even if we start with a brand new plant, we come to it with experts that have a premise on what they want to do. We decide that there's something we want to do differently and drive a process. We spend a great deal of time building up all of this knowledge to say, how is it we're going to deploy? This could be the deployment of one of those systems into manufacturing, a bubble. It could be that catalyst engine. It could be the robots that went into Walmart. And then once I go live, now I'm actually putting it in use. And this inevitably happens when I start with an answer and build the solution to the answer, right? This is the push mentality. I'm going to push the answer into the operation. Once I get started, I expose the gaps, what I thought was important that's not, and now I have to live with it because I built it into the system. I thought those robots wandering the aisles would be cool. We made them look very unimposing to people. We've scrapped the whole business. The company that builds those robots is actually having a little bit of a challenge now because Walmart was their big customer. And then I get to the point where I say, look, now I build workarounds. Those workarounds are costing me more than I'm gaining because it's just this death by 1,000 cuts. And I have to stop. And I decide I do the whole thing all over again. And this is this vicious cycle in industrial operations, in manufacturing, mining, automotive. Again, not because people are not paying attention, but because it's kind of a logical approach. And here's an example of a customer that we actually work with. It's an automotive company, an OEM. They're fixing doors under the car body. So the robot picks up the door, the robot fixes the door, somebody comes in and bolts it up to the car body as it's going into the paint shop. And they said, look, we've got sensors to make sure I know how to pick up the door. We got sensors to make sure I know how it goes into the car body. Why don't we use those sensors that are already on the robots? Let's build a system around it and let's fix the door to the body perfectly every time. Seems perfectly logical. The question nobody asks is, can you do that? Is there a way to prove that really quickly before we build out an entire system to do it? And companies spend a lot of time. And again, I'm not bashing them. What they're doing is they're saying and doing something very logical. I'm going to solve this problem. But if they're not a first principle approach, they don't understand the problem is not that. The problem is actually a couple layers deeper. And what actually happened is they built up a system. They said, okay, let's use the robots to put the parts in place. After a pretty long period of time, significant amount of time, they realized that it wasn't actually working. Now, it was working most of the time, but it wasn't working all of the time. So in fact, it didn't work because every car going down the line has to have the door put up to it. And what we found is by modeling data, which you see over here on the right-hand side, that buried deep within here is a little thread. It's a little string. It's what in manufacturing we would call a gremlin. It's that thing that pops up that we don't know, we can never find. It comes and goes on its own. We thought we fixed it and it showed back up. It's not a gremlin. It's actually a part of the process that if we got deeper into the process and understood what was going on, we could say, look, this process is incapable of holding this tolerance. And we would have ended the process way back here, as opposed to spending time, money, and effort pulling this project forward. And then the next time somebody says, I want to do this, it's like, hey, we tried it. We're not going to go after that again. Here's a different way to take a look at it. What if I actually just start accumulating the data, start to explore it and say, hey, I think I want to look at my process. I want my process to run better. The example I just showed you with the robots placing doors. Connect to the process. I start to explore and exploit the data. Maybe I connect to machines next. Maybe I connect to the materials. I start to look at inbound materials and how the materials work. But I'm creating these connections into different segments of the process. And then once I've made that connection, I start to explore the data and I get value. Just looking at the data and bringing it up for discussion and understanding how the process runs is going to drive the process forward. And what happens is I plateau, then I find a new opportunity, I plateau, then I find a new opportunity. And once I've connected to all those systems, I don't have to connect to them again. If I had laid in the foundation for the sensors on the robots and said, are these going to do what I needed to do? No, but I now have this foundational element. What could I do? What else could I do with these robots to have these robots work better, produce better or more ROI on the production line? It's a different way of looking at it. Look at the data, then start to explore and exploit where you want to go. So the rule of thumb is, in my mind, is follow the suspicion. If you've been doing this long enough, you have a suspicion there's an area, an opportunity, something that we could actually do to drive this process forward. But I don't want to build out a whole process around it. And I don't want to limit where I'm thinking. So I think I got an idea. I don't want to limit it. This defeats this construct of selective attention. So let me show you this video. I don't know who's seen this video. I'm just going to call it the monkey and the basketballs. Most people have seen it. I found a new version of this video. I like to find these videos and use them as examples in different spots. So let me just blow this up on the screen. You know what, we'll do it this way. So here's the premise. The premise is count how many times the ball is passed between the folks with the white jerseys on, and how this actually delivers, or how many times specifically they've actually done this. So if you're watching, and I'll let you replay this video, if you've counted to this point, you should know that there's going to be about 16 of these passes between these folks in the white shirts. But what did you miss, right? If you saw the 16 passes, did you see the monkey, right? How many people saw the monkey the first time? If you've never seen this before, I didn't see the monkey. I said, what monkey? I had to play it. I had to play it in slow motion. I said, there's a monkey in the video. Now, everybody who's seen the monkey, the gorilla, says, okay, I saw that. But did you actually see that the curtain behind them changed color? So while our mind is trained on solving the problem, I've decided the problem is to do the count. What I really find out is that that count is not the problem. There's other things going on in the background that I could start to impact. And I'll leave you with this study. You can read this. It's a short study. It's really fascinating, where somebody did a test and they gave students data and they said, what do you find in the data? What do you find interesting and compelling? There was literally a monkey in the data. If all you did was plot the data, your plot looked like a monkey. And it talks about how few people who started with a hypothesis didn't actually find it. Again, because they're starting with the problem in mind as opposed to getting to the first principles and getting to the data. So a couple of quick examples here. And I think that these are just classes of types of things that we can do. Here's, if you've flown, I used to fly excessively before this disruption and with COVID and all the travel restrictions, and I haven't left the house basically in months at this point, except locally. But if you flew for years, what you remember is you used to fly, and for folks that aren't as senior as me, you'd be on the plane, and then all of a sudden you'd feel coming over the roller coaster hill, and you close your laptop, you start buttoning your stuff up because we're on final approach. I could say we are on final approach because I could tell we come over the little hill. And what they determined is that hill, that process, and this area under this curve is all waste. It's all cost. It's fuel, it's money. So instead of flying to that point, now they start far out and they scribe a line to the end of the runway and they say, give me a gradual glide path. Because instead of flying, stepping down, firing the engine, stepping down, revving the engine, stepping down, now they're just on this simple glide path. If you've flown into Denver on a late flight out of the East Coast, you never feel it until the wheels touch on the runway, because they start literally hundreds of miles before they used to. All of this is possible because all they did was peer into the data associated with a process and say there's a better way to do the process through better use of data and better visibility to how different assets are working in this space. On this side, you see the noise pattern associated with, I think this is SFO, airport. So some engineer is working on a jet engine that runs far quieter because the noise in these neighborhoods is unbearable, right? And what somebody said is, hey, if we just use our data better, we can create a much tighter path. We can create less noise pollution. We could solve 80% of the problem without changing anything except how we run that asset, how we run that plane. There's a video here, you can go in and explains it a little bit. So that's kind of the 40,000 foot literally view. Here's an example from down in an operation. So what you're looking at here is a slug of data that's been brought for analysis. It's kind of historical data. Tell us what's in here was the question that was presented. And what you see is AI, machine learning, algorithmic tools are applied to very chaotic data, noisy data at the front end of this chart. These data points aren't typically in that tight of band. It's just that the math is saying there's nothing unusual about it. Let's just continue on as we're going, right? So the alarm sound, it's like the check engine light came on in my car. I went out this morning, I started the car, went off. I'm not taking it to the shop. If it comes back on, I'll take it, but it's just noise, whatever. So the math has been smooth. And what happened is, at this point, there's actually an alarm that sounds in the data. There's a statistically relevant pattern that emerges from the data that says, pay attention, there's something going on. That was literally 5 days before the alarms in the plant, the alarms in the system, the alarms in the process, where the engineer said, to make a good one of these, I need to know if it's in this range, at this time, so on and so forth. That's where that alarm sounded. Then engineers do what they do. They come out and they work with the process to dial it back in. But what the algorithm told us is that regardless of what they did, the path of that data, the trajectory of that data did not come back into line. So you're working hard and you're smart, and maybe you stayed on a Friday and a Saturday to get this done. The reality is it was not consequential. It wasn't productive. An alarm sounds again, and then the engineers end up on the line again. Here's the issue. What the engineers said was, we don't even know why we would be looking into that pool of data. Some of it's not even my data. Some of it's from other areas. But the math running, the data, all of these different systems, all of this industrial Internet of Things, all of these 3D printers, all of these robots, all of these things that are wired into the network now, in a very simple way can expose data in a secure fashion. You know, I saw CenturyLink as one of the sponsors. I don't mean to pick on one in particular, but my daughter works for CenturyLink, Lumen now. You know, their focus, she tells me about the focus they have about driving this platform for the industrial Internet of Things. That's an enabler to getting the data from all of these different sensors and places up into a position so that they can say, look, 5 days before, we need to get out there and do something because we will have a problem if we don't. So go back to this idea of, you know, we've got these complicated machines, 3D printers, all of these different things, all of the data coming in. We've got these robots, we've got collaborative robots, we've got robots wandering around, we've got legacy operations. By the way, this operation, if you watch the video link, they talk about taking 50% of the lead time out of their operation by using data better. So this is a small company. This is not GE. This is not GM. This is a company with, 50 or 100 employees, a single site manufacturer that doesn't really have dedicated data scientists. They have a good team that does good work, and they're able to take advantage of this and have a dramatic impact. And this is a shop where in the last 5 years, I think they've taken 6,000 people through to show them what lean manufacturing is. This is not a shop that's a train wreck that could be so much better. So we've got everything from the robots and the additive, this ability to grab this data, to accumulate it, to then start to run math and algorithms against it. Think of the differentiation created by companies like Airbnb. companies like Uber, right? I hear it endlessly. Uber's the company with no assets that, is worth, $1 zillion. That's trivial. Look at Amazon. Look what Amazon does with data in the retail space. They're now running fleets of trucks. They're now into medicine, delivering medicines just in time, pharmacological items just in time to people. They can go anywhere they want to go because they didn't start by solving what they thought was the problem. How do we get a prescription to a nursing home faster and better? They started by saying, how do we use data better, more pervasively to drive an operation? So, do we need to harmonize the data to get started, do these big projects and these big budgets, do this study? I'm telling you, we're at a point where Amazon, Microsoft, CenturyLink, Google, all of these folks have given us tools to make the data available. We don't need to clean and harmonize it. We don't need to turn this into a monster project. You don't have to be the largest of the large organization in order to take advantage of this. You have a team. Typically, if you're running an operation fairly well and efficiently, you've got a team that you can launch onto these things quickly. And where to start the process. If we do the study, we're going to pick how many times the ball passes between the folks wearing the white shirts or the black shirts. We're not going to say what in that environment should we be looking at in order to drive the process differently. So I'll leave it with these last thoughts. And I was kind of trying to look at questions. There's a couple questions, but I think we'll take a couple more if folks feel that's valuable. But here's the way to look at the process. I don't care if you're manufacturing or if you're in sales or marketing or any of these different areas. If you start with a vision, with an understanding of what you want to drive, an outcome, not, hey, here's the problem we're going to solve, but the outcome we want to achieve. From that vision, understand the value that has to be derived in order to get there, right? So the vision for VibeCo is I want to be the shortest time. I want to respond immediately to my customers and get them products that they typically need when they're having a problem. So they need it right away. The value is going to be created in different buckets. I've got machines that run faster. I've got people that are better trained. I've got lean applied across my whole shop. I'm putting in data and analytics. And those tactics then fall into each one of those pillars: my people, my process, my technology. Where do I start something really quickly to drive it? And the key is avoiding that bias, because that bias creates delay, that answering the problem before you actually know what the problem is. This concept of digitization versus digital transformation, two different things. Do not confuse them. Putting everything on an app, on an iPad, on a browser on the plant floor is digitization. Giving people a tap on the shoulder so that they can pick up their device and it says, hey, pay attention, the robot at column C2 or the body coming down the line now has passed a certain threshold of quality or whatever. Pay attention. That's going to be the problem you're going to want to solve. And then, what that does is that creates a challenge for the leaders in the organization, because now you've got empowered teams. Now you've got younger folks, you've got more energetic folks, you've got digital natives who are giving us grief and saying, why aren't we doing these things? I could do this for free at home on an app I download for free. And I've got a $450,000 piece of equipment here that I can't even see if it's running or not. So leaders are going to have to figure out how to say, look, let's inspire some of this enthusiasm and excitement and drive the process forward. And as long as it's pull and not push. So the customer needs this. That means my operation needs this. That means my people need this. That's the pull. That gets the best answer into production and into the process as quickly as we can, as opposed to somebody like me wandering in and saying, I've seen this 1,000 times. I'm going to tell you what you need to do. Fix this, push it into the organization. It doesn't work. I've done things at GE where we started in one small corner. We created something of value. A whole team of folks says, I don't even know why we'd want to do that. I go, that's all right. This team thinks it's valuable. They need this. We're going to help them build this. You can come to the party when you want to see if we're doing something interesting. And we watch that blossom and really go viral across an organization that you would think would be all around process and protocol for doing these things. It just turned into a viral situation. So vision, value, tactics, avoid this bias, and really get started quickly, because the data elements, I'm telling you now, already exist. The ability to get them already exists. The ability to run algorithms against them and do it very quickly, very lean, very low cost already exists. If you're not, and if you're taking the next 6 to 12 months to get ready to do things like that with data, I think you need to rethink what you're working on. So we're right up about the time here. I get a little fired up. I apologize. I wanted to leave a little bit of time for questions. Deborah, do we have time for a question or two?
Absolutely, Paul. Thank you so much. Fascinating information. In a meeting from Art Humphreys, in a meeting last week with a very large data management company, they said in response to a question regarding algorithms that they use standard algorithms. Who establishes standard algorithms? Is there any surety in that standard for quality and or for security?
So we would say the same thing. I think you've got to get to what is the definition of standard. So some people will say, I build this piece of equipment, I designed it, I built it, and I actually service it. And this is the real use case. I service it in the field. I know the analytics that get applied to that. I have a standard physics-based analytic that'll tell you that a particular device should run this way. I can tell you that we worked with that organization, and where they were getting like a 15-minute window of warning of an event, we were able to open it up to 170 hours using exactly the same data. So their physics-based analytics had a certain purpose, and that's what made them standard. I will tell you if this machine is about to shut down. I will tell you if our call center is being overrun. I will tell you, whatever that standard is. The problem is, if this is an industrial context, then where you get into trouble with the standard is the data needs to fit. I got to get the data cleaned up so I can fit it into the standard algorithm. And the standard algorithm starts with that bias, right? So if you start to look at algorithms that do things like anomaly detection, process disruption, downtime, those types of things, I think you're looking at something different. So there's a lot of, I got to be careful, because there's a book of rules for doing accounting. You can write an algorithm that says, I can read the accounting data and give you an answer if somebody's, breaching the system, or if somebody's not doing what they're supposed to do, that kind of thing. There are areas where you could be standard, but the further you drop into kind of a manufacturing environment, the less and less standard they become, simply because to be standard, you have to make sure you made up to their algorithm effectively, and that's going to end up being a waste of time. Hope that helps. And look, you can email me. My email's on the slides if you want to have a deeper discussion about that. Anything else, Deborah?
Terrific, Paul. Something that I thought was really interesting when we were first talking was related to workforce development and workforce training and artificial intelligence. Would you mind sharing that story with the group?
Yeah. So there's a real opportunity in the workforce now in manufacturing. So first of all, we can bring manufacturing into areas where we just have good foundational skills, math, science, STEM type skills, because if I couple that with the algorithm in general, let's just say machine learning, AI, I can give that person superpowers. So I can be in an environment, if I were in your region, I would say, look, we have the best primary schools, secondary schools, we have great universities. We provide the product that manufacturing companies need, which are people who are good thinkers, that have good work ethic, and they'll come in. And now if you work with them as an organization and say, just like you would say, hey, Deborah, I want to see you succeed. I'm going to pair you up with a mentor. Here's someone you should talk with on a regular basis that's going to give you some insights on how to just be a little bit better. That's what you would do with these algorithms, AI, machine learning. Pair the operations folks up with this AI mentor. Not really that much different than somebody who's been doing it for 30 years. But at 30 years in the role, we're less agile at the very time that we're at the peak of our understanding of a process and our ability to diagnose things. So that makes it very difficult. So how do you keep people from being really worn out completely while they're the smartest, but then take people who are really energetic, but they've never seen this before, they don't understand it. You can embody that in the systems. And I'll tell you, you need to be careful, because we talked about this a little bit. There's a great book, Kevin Sullivan, the pilot of a Qantas QF-72, an aircraft, Airbus A380, where the machine decided on its own to start to act erratically and almost kill the entire the crew and everyone on board. This point at which we're going to just turn our plants over to the algorithm, I think we're a ways away from that. I don't even think we've got the self-driving thing completely locked down. If you think in terms of the human who's got superpowers because they're paired with a machine that can act a little more human, I think that's a huge opportunity. Does that help? Oh, I don't have you. You're mute.
Sorry about that. I'm just copying to share with everyone, because that was a really fascinating story. I actually still have it up on my browser.
Hey, so somebody asked a question, what books? If you have not,
yes,
if you're in manufacturing, you haven't read The Goal, you got to read The Goal. Eli Goldratt. It's available everywhere. You can get a digital copy if you want. It's written like a novel. It talks about manufacturing like a novel. It's a well-meaning plant manager who's about to lose his job in a small town where they're running out of they're running the business out. But it gets you thinking about, not just because Goldratt is big about thinking and learning how to think. I saw him, the first plant I ever ran, the owner of the company sent me to a seminar. And the thing that I remember to this day is he said, and I assume this is true, he said the Israeli army, when they award a medal of heroism, somebody came through across the wire and threw a hand grenade into the camp, the first thing they do is open up an inquiry to determine who messed up, that they had to give somebody a medal of, for heroism. So if you think about how we attack things, it should just be typical days. Things run very successfully and predictably. That's where we want to get to. And that book, The Goal, is a great book to read. Another book I like, an older book, is Beginning of Infinity. Team of Teams, McChrystal, is a great book because it's great about teams. It's also a big data book. If you're doing some things around big data, you can see what they're doing around big data. So that's another one I would recommend. I think we're a little bit over.
Okay.
Do we?
Yep.
We're
I'm
good, or
just
we
trying
want to
get a few things in the chat. Does anyone else have any questions for Paul? And
I hope this helped. Like I said, we'll put the slides up. You'll be able to download the slides if you think there's any value. My email address is there. Just don't hesitate to contact me. It'd be great to talk with folks if they got particular questions. But Deborah, thanks so much. Sheila, thanks so much for having me. Hopefully this was worthwhile for everybody. And it's always fun to see you guys do such a great job with the sponsors and the folks that show up for the event. So thank you.
thank you so much, Paul. Thank you so much for presenting and joining us today. That was just fascinating. And I'm also just gonna, if it's okay with you, drop your email address in the chat.
Please do.
Okay, and we will be getting your slides posted to your link in Socio, to the presentation link in Socio, along with the recording. So thank you so much to everyone. And thanks again, Paul, really appreciate you. At least this time you didn't have to come from Pennsylvania, because then last week we would have been worrying about the snow or your flight. But it was pretty funny. Paul and I were on a call and I opened my back window and he goes, "Is that snow?"
Snow already.
Yeah. So, and he still had just a little balmy weather up in Pennsylvania. So thanks so much everyone for joining us today. Please take a look at the expo hall in Socio. We have just a fantastic lineup of speakers and presentations for you today. So again, I hope you can really enjoy the day and participate in the sessions and, you know, and be interactive since we can't be there together. You know, all of the speakers would love for you to raise your hand, share your viewpoints. Well, the breakout sessions will be smaller groups, so you can have that opportunity to really have the chance and get to know the speakers and share their wisdom, garner their wisdom from them. So thank you all so very much.
And it looks like the
Thanks,
next
everyone.
session starts at 10:15 a.m. Mountain Time. So
Yeah,
get yourself a little break and then come back on. And hopefully you created your agenda under my agenda. I think the link becomes available. The video streaming link comes available about 15 minutes before. Is that
yeah,
right?
yes.
Okay. So then you'll be able to join us on the next session. So we'll see you then.
Okay, thank you, everybody. Thanks, Sheila, so much. Thanks, Paul.
Bye-bye.
Have a great day. Bye-bye.